GATE 2014 set 3 electrical question number 39. The load shown in the figure absorbs 4 kilowatt at a power factor of 0.89 lagging. Assuming the transformer to be ideal, the value of reactance X to improve the input power factor to unity is given by. For NPTEL reference, you can refer to lecture number 8, Transformers, Voltage Regulation and Efficiency of the NPTEL course Electrical Machines by Professor G. Bhuvaneshwari, Department of Electrical Engineering, IIT Delhi. Coming to the useful data, we know for an ideal transformer, the transformation ratio is defined by N1 by N2 and the voltage V1 and V2 is given by V1 by V2 equal to I2 by I1 equal to N1 by N2, where I1 is the reflected current at the primary side of I2. Now for non-ideal transformers there are series parameters also along with this. So now in this series parameter, if we want to transfer it to the primary side, it will become R2 dash, which is equal to R1, because R2 dash means the reflected resistance of the secondary side to the primary side, which is also R1, and we define R1 as R2 into N1 by N2 whole square, because we are transferring to the primary side. Now if primary turns ratio N1 is greater than N2, this will be mode. Since V by I equal to Z, if V is mode, I is less, Z is even more. So at the HV side, high voltage side, the impedance increases. That's why N1 by N2 whole square into R2 is the transferred impedance at the primary side. Now coming to this concept that if you have a current I, we can break it down into two parts. If the power factor angle is phi, I sin phi and I cos phi, and I sin phi is the reactive component and I cos phi is the real component. Now I sin phi into voltage V into I equal to power. This is the reactive power. This is the reactive power, and since this is capacitive dominance, since the I is leading, so now we can find the value of capacitive impedance, that is the reactance offered by the capacitor Xc, by this equation, where Q net is the reactive power supplied by the capacitor and this is V square by mod Xc. Coming to the solution, this is the circuit as shown in the figure. Now from this 4 kilowatt power is absorbed by the load, so power is 4 kilowatt load power, and the power factor angle is phi 2, and given cos phi 2 equal to 0.89, V2 is given as 110 volts. This is the V2. So now from here I2, this I2 load current is defined by PL divided by, since this is a single phase circuit, so V2 cos phi 2. This is the current and this is the magnitude, and this is cos phi 2 equal to 0.89 lag. That's why the angle becomes minus cos inverse 0.89. So this is the angle. So I2 value is coming out to be 40.858 angle minus 27.13 degrees. Now in transformation ratio we know 2 by 1 equal to, now this current is I2 dash, so 2 by 1 equal to I2 divided by I2 dash. So we want to find out I2 dash, which is equal to I2 by 2 equal to 20.43 angle minus 27.13 degrees. Now the value of I2 dash equal to 20.43 angle minus 27.13 degrees. So like this, V1 is there and I2 is like this, I2 dash, and this is 27.13 degrees. Now to make it unity power factor, what we do, we break I2 into two parts. This is I2 cos phi, where phi equal to 27.13 degrees. Let's say phi 1. This is I2 dash, and this is I2 dash sin phi 1. If this X reactance, that is provided a current Ix such that I2 dash plus Ix makes UPF, that is inline current with the V1, then we can say it is UPF operation. So what Ix is equal to I2 dash sine phi 1. So value of x equal to V1 divided by Ix. Now V1 equal to, as you see in this diagram, 2 times 110 volts by transformation ratio, because V1 by V2 equal to 2 by 1, which is implying V1 equal to 2 times 110 volts, since V2 is 110 volts, since this is 220 volts. Now this coming back to this, which is 220 divided by Ix. Ix is 20.43 sine 27.13, which is coming equal to 23.61 ohms. So the answer is 23.61 ohms should be this capacitive reactance value, because it is making the lag UPF, so it is providing reactive power, and it is equal to 23.61 ohms. So the answer is 23.61 ohms.